Gravity is necessary for life on Earth. Even though it is vital to our existence, Earth's gravity is relatively weak compared to other celestial bodies in the universe. The most massive celestial bodies have such strong gravitational pulls that not even light can escape. These are known as black holes.
Black holes are created when a star can no longer create energy from nuclear fusion and collapses under its own gravity. This creates an infinitely small and infinitely dense point known as the singularity. However, the singularity is not the part of the black hole that we see. What we see is known as the event horizon. The event horizon is the border around a black hole where light can no longer escape. Since no light can escape from past the event horizon, it is impossible to see anything from within the black hole.
While it is true that nothing can escape a black hole, it is possible for black holes to evaporate over time.
Black holes evaporate due to a process known as Hawking radiation. Hawking radiation was theorized by Professor Stephen Hawking. His theory explains how black holes radiate particles. The concept of Hawking radiation goes as follows. Pairs of microscopic particles, one with positive mass and positive energy and the other with negative mass and negative energy, pop into existence and quickly destroy each other. This process occurs rapidly throughout space, like so.
The idea of negative mass may seem confusing and illogical. It is important to note that negative mass can only exist on a molecular level. Matter with negative mass is too unstable to exist in large quantities because it spontaneously combines with positive mass to create zero mass. While the spontaneous creation of particles and energy seems to violate the laws of conservation of mass and energy, Hawking radiation is still possible. Consider the following analogy.
Let's say you borrow $1 as a loan from the United Bank of Money. Assuming that there is no interest, you did not gain nor lose anything. While you did get $1, you also acquired a debt of $1, which is virtually the same as having negative $1. When you pay your loan back, the positive dollar and the negative dollar cancel each other out, giving you $0. Opposite values cancel out.
By adding particles of opposite masses, the amount of mass in the universe is not changed.
This process may seem pointless because the two particles eventually destroy each other. However, when Hawking radiation occurs on the event horizon, the particle with positive mass has enough energy to escape, while the one with negative mass gets sucked in. This makes the black hole lose mass.
While this does mean black holes evaporate, the process is very slow. It is estimated that the largest black holes can take up to 10 to the 100 years to completely dissolve. Sadly, we will not live long enough to see a black hole evaporate. Regardless, Hawking radiation is an interesting concept which completely changed how scientists view black holes.